So as a part of the continuation of the sol gel method, so and in the previous lectures we have gone through the nanomaterial by synthesis methods and applications of nanomaterials by sol gel method. So where we have seen three different types. One is a supercritical drying, thermal drying, and freeze drying, and there are steps involved. Hydrolysis. First step is the hydrolysis method. Second step is the condensation method, and third step and fourth step is aging and drying method. And finally, we get the calcination, right? So the sol gel process, as we have seen this, the sol gel process is more chemical method. This all we have seen in our previous lecture. Just a couple of minutes, we will just have a glance for the synthesis of various nanostructures, especially metal oxide and nanoparticles. In this method, the molecular precursor, usually metal oxide, is dissolved in water or alcohol and converted to gel by heating and stirring by hydrolysis or alcoholysis. Since the gel obtained from the hydrolysis or alcoholysis process is wet or damp, it should be dried using appropriate methods depending on the desired properties and applications of the gel. For example, if it is an alcoholic solution, the drying process is done by burning alcohol. After the drying stage, the produced gels are powdered and then calcined. The sol gel method is, we know that sol gel method is a low cost equipment method which can be done at room temperature, and there is a good control over the composition. The chemical composition can be controlled over the composition of the product. Chemical composition of the products can be controlled, and it can be done at very low temperatures. That's why people prefer sol gel method, because it is a low cost method, right? The sol gel method can be used in the process of making ceramics as a molding material and can be used as an intermediate between thin films of metal oxides in various applications. The materials obtained from the sol gel method are used in various optical, electronic, energy, surface engineering, biosensors, and pharmaceutical and separation technologies such as chromatography. So till this extent we have seen in our previous lecture. So the sol gel method is a conventional, I think this also you have seen, the sol gel method is a conventional and industrial method for the synthesis of nanoparticles with different chemical composition. Sol gel method is a conventional industrial method. So the conventional industrial method for the synthesis of nanoparticles with different composition, different chemical composition. So the basis of this sol gel method is the production of homogeneous sol from the precursors, so the precursors obtained from the oxides, and conversion into gel. So the basis of the sol gel method is the production of homogeneous sol from the precursors and its conversion into gel. The solvent in the gel is then removed from the gel structure. The solvent in the gel is removed from the gel structure and the remaining gel is dried. The solvent in the gel is then removed from the gel structure and the remaining gel is dried. So the properties of the dried gel depend significantly on the drying method. So the properties of the dried gel depends significantly on the drying method. So in other words, the removing solvent method, we can tell that, in other words, it is nothing but, we can tell it's a removing solvent method. It is a removing solvent method is selected according to the application in which the gel will be used. In other words, the removing of solvent method is selected according to the application in which the gel will be used. So dried gels in various ways are used in industries. Such as surface coating, building insulation, and the production of special clothing. So in other words, the removing solvent method is selected according to the application in which the gel will be used. Dried gels in various ways are used in industries such as surface coating, building insulations, and other production of special clothing materials. And moreover, it is worth mentioning that by grinding the gel by special mills, it is possible to achieve nanoparticles. So So that is what, as soon as the gel is made, by grinding the gel by special mills, it is possible to achieve nanoparticles. Nanoparticles can also be achieved in this form. That is, that by grinding the gel, okay, by special mills like ball milling and all, right, it is possible to achieve nanoparticles. So some of the examples of gels are curd, cheese, butter, etc. And emulsion. These are the emulsion also. These are the type of colloidal solution, colloidal method. We will come to this colloidal method in the coming few slides. So emulsion is a process that these are the type of colloidal solution in which both the dispersed phase and dispersed medium are in their liquid state. Some of the examples of emulsion are milk, right? Milk, like cold cream, like which is like a gel, and oil in water, which is due to the interference and all. Okay, oil in water, that is what thin films like gel. Okay, so etc. So these are some of the examples of gel. There are different types of gels. So two most common types of gels are mostly the agarose and polyacrylate solutions. Polyacrylate gels. So these are the different types of gels. One is the agarose, and second one is polyacrylamide. So these are the different types of gels. So each type of gel is well suited for different types and sizes. Each type is fabricated for its own different type and size. Okay, different type and size of the analyte. So polyacrylamide gels are usually used for proteins and have very high resolving power for small fragments of DNA particles. So which will be up to 5 to 500 basic pressure. Right. So these are some of the examples of gel. So the most common types of gels are agarose and polyacrylamide gels. So each of this type has its own contribution, right? For different types and size. And moreover, polyacrylamide gels are used for proteins and very high resolving power for small fragments of DNA. So the small fragments of DNA, the size should be 5 to 500 BP. So next consent method, as we have seen, there are different types of fabrication methods. So we have seen there are different types of fabrication methods. One is a top-up process, a top-down process, and other is a bottom-up process. So in bottom-up process, we have different methods of fabrication. One is a sol-gel method, other is colloidal method, solution phase reduction method, and electrode deposition method. So in the previous lectures, we have seen what is sol-gel method, and we have seen some of the examples of gel, agarose and polyacrylamide gels which are used for DNA particles and all. Right, and the next method in which nanomaterials can be fabricated is a colloidal method. Right, so colloidal method. So this colloids in solution. So nanoparticles synthesized by chemical methods form colloids. So nanoparticles synthesized by chemical methods. The synthesization of nanoparticles by chemical methods forms colloids. Of course, we have sol-gel method also, where the nanoparticles can be synthesized. But the advantage of using sol-gel process is it can be operated at low temperatures. And the cost equipment for synthesization of a sol-gel method is very, very cheap. That's why people go for sol-gel method. And if you come to another fabrication method, colloids in solution, nanoparticles synthesized by chemical methods form colloids. So two or more phases. Phases means conversion, phase transition. Two or more phase transitions. Phase transitions like solids, liquids, or gases. So solid to liquid, liquid to gas, gas to liquid, liquid to solid. So these are nothing but the phase transition. Phase transition methods. That is what? Two or more phases like solids, liquids, or gas of same or different material coexist with the dimensions of at least one of the phases less than a micrometer. Two or more phases. Phase transition phase transition in different material coexist with the dimensions of at least of the phase less than micrometer. So phase transition, while observing the phase transition, that is two or more phases like solids, liquids or gas of same or different material coexist with the dimensions of at least one of the phases less than a micrometer. Right. So these colloids in solutions can be a particles, maybe a particles or plates or fibers. So nanomaterials are a subclass of colloids. So what are colloids? Colloids are the nanomaterials or of subclass of colloids in which the dimensions of colloids is in the nanometer region. So the dimensions of colloids will be in the nanometer region, right? So that's what we are telling. So nanoparticles synthesized by chemical methods form colloids. So two or more phases like solid, liquid or gases of same or different materials coexist with the dimensions of at least one of the phases less than a micrometer. So these colloids may be a nanoparticle, may be a particles. These colloids can be a particles or plates or fibers, right? So nanomaterials are a subclass of colloids. Nanomaterials are subclass of colloids in which the dimension of the colloid is observed to be in the nanometer region, right? So what is this colloidal synthesis method? So if you come to what is this colloidal synthesis method? Colloidal method is a traditional method of synthesizing. Inorganic nanocrystals, including semiconductors and metals. Right? So colloidal method is a traditional method of synthesizing inorganic nanocrystals, including semiconductors and metals. So microemulsion is a transparent, thermodynamically stable liquid mixture of isotropic oil, water and surfactant, often combined with surfactant. So colloidal method, what is this colloidal synthesis method? Colloidal method is a traditional method of synthesizing nanoparticles. It's a traditional method of synthesizing nanoparticles or nanocrystals, inorganic nanocrystals. This all comes under the chemical composition, right? It's all under the chemical roots. So including semiconductors and metals. So colloidal method is a traditional method of synthesizing inorganic nanocrystals, including semiconductors and metals. So in this, microemulsion is a transparent, thermodynamically stable liquid mixture of isotropic oil, water and surfactants, often combined with surfactants. Right. So what are the advantages of these colloids? So these colloids, they enlarge the circulatory volume due to immense volume size. They enlarge the circulatory volume due to its immense volume size. They elevate the osmotic pressure. They elevate the osmotic pressure. They let disbandment of insoluble particles. Such as gold, silver or fat contents, right? So that's what, these are the advantages. What are the advantages of colloidal particles? They enlarge the circulatory volume due to immense volume size. They elevate the osmotic pressure. They let disbandment of insoluble particles such as gold, silver or fat. Right. So what are the types of colloids? Is, there are different types of colloids. One is the emulsion technique. That is what microemulsion or emulsion. Emulsion is a colloid between two or more liquid with one consisting dispersion of another liquid. Another liquid. Right. Another type of colloid is the foam. It consists of gas dispersed in solid or liquid, and also it consists of aerosols, right? It consists of a minute liquid of solid particles in a gas. That is what we call it as aerosols. It consists of a minute liquid or solid particles in a gas, right? So if you come to the types of colloids, we have emulsion and foam. So emulsion and foam are the two types, are the types of colloids. So emulsion is nothing but a colloid between two or more liquid with one consisting a dispersion of another liquid. Foam, it consists of a gas dispersed in solid or liquid, right? And also aerosols, it consists of a minute liquid or solid particles in a gas. So if you come to the diagram, see we have this colloids. You can see here the colloids, right? Colloid is a mixture of two phases of matter. So colloid is a mixture of two phases of matter. One is emulsion method, smoke, foams, milk, which are taken in the form of gel and foam, and other as the clouds, the gel and foam. So two phases. One phase is in the form of emulsions, and other form will be in the form of aerosols. One will be like smoke, one will be like fog, some will be like foams, some will be like gels, and some will be like milk, and some will be like clouds. So this is what we see about the gel and foam method, and this is what the clouds. We can see the cloud. We can see some certain clouds-like features, right? So, and other is the milk form. That is what we tell. Milk means milk and cloud. So, a mixture of two phases of matter. So, mixture of two phases of matter forms colloids, right? So that's why emulsion. That's why we call emulsion. It is a colloid between two or more liquid. Emulsion between two or more liquid with one consisting a dispersion of another liquid. Other is the foam. Foam, it consists of a gas dispersed in solid or liquid. So other is the aerosols. It consists of a minute liquid or solid particles in gas. So this is what we talk about the different types of colloids, and this is what we talk about the colloidal synthesis method. So that's what we are telling. Colloidal synthesis method, a traditional method of producing nanoparticles, synthesizing inorganic nanoparticles, including semiconductors and metals. So colloidal methods is generally a synthesis method. So that which nanoparticles can be fabricated by even including inorganic materials like inorganic nanocrystals, including semiconductors and metals, right? So this is what synthesis method and different types of colloids. Now, which technique is used in colloidal system? Right. So what are the techniques? Previously we have seen what is colloidal synthesis method, and we have seen certain different two types, and what are the advantages of colloids. And now we should see what is a technique that is used in colloidal system. So the technique nephlometry is one of the technique. In which the colloidal system is used. Right. So colloidal system. So nephrometry is a technique that is used in a colloidal system, right? So nephrometry, it's a technique, right? It deals with the analysis of colloidal system. That is what it deals with, analysis of colloidal system. It is based on the scattering of light. It is based on the scattering of light by the particles suspended in liquid. So nephrolometry is one of the essential technique that is used in colloidal system. So that nephrolometry deals with the analysis of colloidal system, and it is based upon the scattering of light of light by particle suspended in a liquid. When a particle is suspended in a liquid, the light gets scattered, right? That is what we call a nephrolometry, right? So this is what the technique that is used in colloidal system, right? Okay. So if you go for the classification, of colloids, the types of colloids, the classification. If you see for the classification, the types of colloids include sol, emulsion, foam, and aerosols. So this is how the colloids are classified. Colloids are classified as sols, emulsion, foam, and aerosols. So sol is a colloidal suspension. With solid particles, colloidal solution with solid particles in a liquid. Sol is a colloidal suspension with solid particles in a liquid. right? Sol, right? So that is what emulsion is with solid particles. The emulsion is between the two liquids. Emulsion is between the two liquids. So if you see here, this is what the example of stable colloid. This is what the example of stable colloid. This is what the example of stable colloid, and this is an example of unstable colloid. Unstable colloid. See here, the particles are sedimented, aggregated. Here, this position is what the aggregation, and this position is what we call it as the sedimentation, right? So this is what the example of stable colloids and the example of unstable colloids. Okay. So the type of colloids includes the classification. The types of colloids include solution, include sol, emulsion, foam, and aerosol. Sol is a colloidal suspension with solid particles in liquid. Solid particles in liquid. Emulsion is between two liquids. So what is the principle of colloidal solution? What is the basic principle that is included in colloidal solution? So this basic principle, also known as colloids or colloidal suspension, The colloidal solution can be defined. This colloidal solution can be defined by a mixture of particles of substance. Right? Defined as a mixture of particles of substance. The colloidal solution can be defined as a mixture of particles of substances. These particles are microscopically dispersed. And soluble or some are soluble and some are insoluble, which are suspended in a fluid regularly. Right? So which are when they suspended in a fluid regularly. That's why when we talk about the principle of solid solution, also known as we call it colloids or colloidal suspension. That's why we call it as colloids or colloidal suspension. The colloidal solution can be defined as a mixture of particles. Particles of substance. The colloidal solution can be defined as a mixture of particles of substances. So these particles are microscopically dispersed. Either dispersed in a soluble liquid or insoluble liquid, which are suspended in a fluid regularly. So that is what we call it as, also known as a colloid or colloidal suspension. The colloidal solution can be defined as a mixture of particles or substances. These particles are microscopically dispersed and soluble or insoluble, which are suspended in a fluid regularly. Right? So this is what the principle of colloidal solution, and that is what the classification of colloids. The classification of solid includes sol, emulsion, foam, and aerosols. And sol is a colloidal suspension with solid particles in liquid. See, this is what the solid particles in liquid. This is what the stable colloid we call it as, and this is what the unstable colloid. So here we have some particles that are getting. So this is what the particles. These are the particles that are immersed in liquid, right? Suspended in liquid with solid particles in liquid. Emulsion between two liquids. Here we see these examples of an unstable colloid where we have aggregation and sedimentation, right? So which are suspended in fluid regularly. Now, what are the 7 types of colloids? Basically, on the physical state of the dispersion, based on the physical state of the dispersion medium, and of the dispersed phase means solid to liquid to gas, based on the phase transitions, right? So based on the physical state of the dispersion medium of the dispersed phase, colloids can be classified into 7 types. That is what, based on the physical state of the dispersion medium, and of the dispersed phase, colloids can be classified into foam, as we have seen, solid foam, aerosols, emulsion, gel, solid aerosol, sols, and solid cells. So these are the different types of colloids. So basically we call it as 7, but it can be aggregated to 9. So because some are formed by their like foam. We call it foam, the solid foam, aerosol, emulsion, gel, solid aerosol, solutions, solid solutions, solid cells. So these are the some different types of colloids, right? So these types of colloids, types of colloids are based on the physical state of the dispersion medium. based on the physical state of the dispersion medium and of the dispersed phase. Colloids can be classified into foam, solid foam, aerosol, emulsion, gel, solid aerosols, salts, and solid salts. Right. So some of the examples of solid solution are, colloidal solution are, we have gelatin. Some of the examples of colloidal solution are, we have gelatin, right? So like muddy water, we know muddy water, right? Gelatin, muddy water, butter, right? Blood, and colored glass, right? Colored glass. So these are some of the examples of colloidal solution. One is a gelatin we call it. We call gelatin or gelatin we call, and as a muddy water. Muddy water means water that we take from mud. That's what muddy water. And other is a butter. Butter means we know, right? And the blood, which is also sometimes they have some different types of a thick blood and thin blood, right? So that is what some of the colloidal solution, blood, right? And other is a colored glass, right? So these are the different types of examples of colloidal solution, right? So what are the basic method? What are the two basic methods of forming a colloid, right? So what are the two basic methods of forming colloid? What are the two basic methods of forming a colloid? There are two basic methods for forming a colloid. That is reduction of larger particles to colloidal size, and condensation of smaller particles into colloidal particles. There are two basic methods of forming a colloid. First one is reduction of larger particles to colloidal size. And second one is reduction, and other is a condensation of smaller particles. Like example, molecules into colloidal particles. Right. So these are the two basic methods of forming a colloid. So first is reduction of larger particles to colloidal size, reducing the larger particles to colloidal size, right? A condensation of smaller particles into colloidal particles. So these are the two different methods of forming a colloid, right? So that is what. First one is the reduction of larger particles to colloidal size, and second one is condensation of smaller particles into colloidal particles. So example, the smaller particles in the molecular size, right? Examples like molecular size. Right. So what are the components of colloids? What are the components of colloids? The components of colloid solution are the dispersed phase, as we have seen in our previous slide. So based upon the physical state of the dispersion medium of the dispersed phase, colloids, how the colloids are classified. Similarly, the components of colloidal solution are the dispersed phase and the dispersion medium, right? The components of the colloidal solution are of the dispersed phase and the dispersion medium. So the solute-like component or the dispersed particles, in a colloid form, the solute-like components or the dispersed particles in a colloid form the dispersed phase. So then how the dispersed phase is formed? The solute-like component or the dispersed particles in a colloid. The dispersed particles in a colloid, the solute-like component of the solution-like component of the dispersed particles in a colloid form the dispersed phase. And the component in which the dispersed phase is suspended is known as the dispersing medium, right? So these are the two different important components of colloids. What are those? First one is the dispersed phase. And second one is the dispersing medium. So these are the two different types of, these are the different components of colloid solution. So that is the components of the colloid solution. The components of a colloidal solution are the dispersed phase and the dispersed medium. Now how this dispersed phase and dispersed medium are created? So the dispersed phase is created where the solute-like components are the dispersed particle in colloids, right? In a colloid, we have the solute-like component or dispersed particles in a colloid form the dispersed phase, and the components in which the dispersed phase is suspended. The components in which the dispersed phase is suspended is known as the dispersing medium. So these are the two different components of colloids. One is the dispersing phase and other is the dispersing medium, right? So the dispersing phase and dispersing medium are formed just like are formed by solute-like components or dispersed particles in a colloid, and the component in the dispersed phase is suspended in one of the dispersing medium. So what is the most common colloid? So what is the most common colloid? The most common colloid is albumin. Albumin is the most common colloid. Albumin is the principal natural colloid comprising of 15 to 60% of plasma proteins. So albumin is a common colloid which is consisting of 50 to 60% of plasma proteins. It contributes to 80% of the normal octonic pressure in health, right? So this is what the most common colloid, that is albumin, right? So what are the physical properties of colloid solutions? So the physical properties of colloid solutions are the stability. Physical properties of colloid solutions are the stability. Stability, that means stability, that colloids are relatively stable in nature. So colloids are relatively stable in nature. The particles of the dispersed phase are in a state of continuous motion. The particles of the dispersed phase are in a state of continuous motion, and they remain suspended in a solution. Another is the filterability. One is the stability. Physical properties of colloid solution. One is the stability and is the filterability. Stability and this is the filterability. 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 Right. So one is the stability, where colloidal solutions are relatively stable in nature. So here the particles of the dispersed phase are in a continuous motion and remain suspended in a solution. And there is a filterability, where colloids require specialized filters, known as ultra filters for filtration, where they require special filters known as ultra filters for filtration. So these are some of the properties of colloids. So what is the most common colloid is the albumin. Albumin is the most common colloid. And stability, if you come to the physical properties of the colloid, we have one is the stability and other is the filterability. So stability and filterability are the two physical properties of colloidal solution. So if the filterability requires some filters, which are generally specialized filters, which are known as the ultra filters or filtration, right? So these are the physical properties of colloidal solution. So if you come to the characteristics of colloidal solution, colloidal shows the Tyndall effect. One of the important characteristic of colloidal solution is colloidal shows the Tyndall effect, which comes from the Brownian motion. It is called the Tyndall effect. Right? Which is called the Tyndall effect. That is, colloidal particles can scatter a beam of light. Can beam of light and make them path of visible. Colloids also exhibit Brownian movement. Right? That is zigzag random movement of colloidal particles in the solution. So colloids show the Tyndall effect, which comes from the Brownian motion, right? So that is Brownian motion, like zigzag motion. So colloidal particles can scatter a beam of light passing through them. Colloidal particles can scatter beam of light, the beam of light passing through them, and make the path of light visible. So that's why colloids also exhibit, we call it as Brownian motion, that is zigzag random movement or random movement of colloidal particles in the solution. So these are the one of the important characteristics of colloidal solution. Colloidal solution through the Tyndall effect. So Tyndall effect in that colloidal particles can scatter beam of light, pass through them and make the path of light visible. Right? Colloids also exhibit Brownian motion, that is a zigzag random motion of colloidal particles in a solution. Right? So if you come to the properties of solids, we have there are different properties of solids. Okay, so we'll end up with this. We'll end up with the characteristics of solid, and we'll see what are the properties of solids in the next coming lectures.
Like, share and subscribe. Hit the bell icon for more updates.